First thing, I'm not going to draw Grand Bahama Island. Since the eye of a hurricane passes over Grand Bahama Island, it is moving in a direction theta equals 53 degrees, north of west. North of west means?
Northwest.
Northwest.
So what if it said, now, what if it said 53 degrees west of north? What is that?
Same
Northwest.
thing.
But the angle would be where?
Going down.
This is 52 degrees north
On the
of
other
west,
side.
so it'd be west of north. All right? Now, and it says it's moving at a speed of 33.0 kilometers per hour. Exactly 3 hours later, meaning it's moving in this path for how long? 3 hours. Exactly 3 hours later, the course of the hurricane shifts due north. And its speed slows to velocity equals 20 kilometers per hour. As shown below. How far from Grand Bahama is the hurricane 5 hours after it passes over the island? The complete path is 5 hours. 3 of those hours it spends here. How many hours does it spend going 20 kilometers per hour? 2. 2 hours. The rule is, if you have vectors that you are trying to add, if you have vectors that are not perpendicular, you break them up into component vectors. These vectors don't make a right angle. So you can't just use Pythagorean theorem here. You can't just apply this, find the time, or find the distance for this, find the distance for this, square root them and get the answer. If you do, you may get an answer, and in this case, it may get close to right, but it won't be right in all cases. It's a chance you take. Here, I break it up into component vectors and then make a triangle. My component vectors for this one are, for this triangle here, 53 degrees. What's my hypotenuse for this triangle? 33 kilometers per hour. And what's the time that it's traveling 33 kilometers per hour? 3 hours. For a total distance of what?
99.
Talk to me.
99.
99 kilometers.
How did you get that?
T times V to solve for X. Time is 3 hours. Speed is 33 kilometers per hour. When I'm solving for X, it's 3 times 33. 99 kilometers. So now I have this triangle at 53 degrees with a displacement in the west of north direction, a north of west direction, 99 kilometers. I need to break this up. I need to find these components. What can I do to find these components here? To find these sides here, what can I use? I can use some trigonometry. Which one would I use first? Which one you want to use? Sine. Sine what?
Theta.
Theta is what? 53. Sine 53 is what? Sine 53 is what? What's the opposite side? Y'all know what sine is? What's the opposite side? Huh? Where's the opposite side? This side, this side?
That's
This right here.
yeah.
This is my y1. This is my x1. Sine 53 is what? Huh? y1 over what? Over 99. y1 over 99. I need to solve for y1.
Ain't you multiply 99?
That's what you're supposed to do. What you got? Brandon, I think that kind of thing you want to take notes on like a tablet computer or something, man. I don't know how you're taking notes on that laptop.
39.6.
What is it?
39.6.
39.6? 99 times sine 53. I need somebody to back that up.
247.
You got 5247.
I got 5247.
Okay. So I'll take 5247 for my y1. 5247 kilometers. My x1, what trig function should I use to find this side? Huh? Cosine. Cosine, what's my theta? 53 equals x1 over 99, my hypotenuse. Give me that one.
I got the same thing.
The Y1 is 79.1.
You're saying that the one you gave me before is wrong?
Yeah.
79.1.
Yeah.
What's my cosine 53? What's this? What's x1?
59.57.
59.57. Saying x1 is 59.57. Now, I've taken care of this. This one up here. You use some brain power. First of all, what's the displacement in this direction? What's the displacement? What's the displacement in this direction?
40 kilometers.
40. 40 kilometers in this direction. And what direction is that? What direction is that? On our paper, though, in graphic terms, what direction is that? Who said it? Y. That's my Y2. What's my Y? What's my X2? What's the X component of this second one? What direction does it go in the X direction? How far does it go in the X direction? 0. There is no X component. X2 is 0. So I broke them up, and I try to break up both of them into their component vectors. Now, last thing I do, I make a big triangle, because that's all we're looking for. We're looking for this displacement right here. I make a triangle. With this triangle, I use, what is my x1?
59.57.
59.57. What's my x2?
You mean your Y1?
What's my, did I say y the first time?
No, you said X.
Okay, so my x1 is 59.57. What is my x2? 0. What is my y1?
79.1.
79.1. What's my y2?
0.
40. So I have 59.57 plus, should be 119. 119.1. What can I use now to find the displacement? Yes, sir. Let me what you got.
Question is those numbers squared?
You're doing Pythagorean theorem, like you would do any triangle. Do the Pythagorean theorem like you would always do it. Yes, sir.
How do you get 119.1?
My y2, my y1 plus my y2. The y movement of this vector and the y movement of this vector all together.
Mr. O. So we ain't messing with that 33 km no more.
We used it to find this one here, the displacement of this line here. That displacement. That's the only way we were able to
We
find
put a
it.
whole nother triangle.
Yeah. We found this so we can find the components. Get all that.
133.17.
133.17. What?
Kelvin.
Yeah.
One 33. Next one up.
This is fun. It is